Welcome to the Digital Amateur Television Experimenters Night. This is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. Do you realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world? Also participate in the night by coming up to the Queen's Domain club rooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
Okay, this is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania with our DATV Experimenters Night. And I've got Lance, VK7ZA, in the studio with me. Evening, Lance.
Evening.
How you going?
Well, thank you.
Excellent, excellent, excellent. I'll just get underway with Acknowledgement of Country. I wish to acknowledge all Tasmanian Aboriginal people as the traditional owners of the land and pay my respects to elders past, present and emerging. For they hold the memories, the knowledge and the culture and hopes of Aboriginal Tasmania. Now, I've got Lance in the studio because we have a Discord channel that many people, many Reast members and others contribute to. And there's been a bit of a discussion around NBN and specifically Ingres of 80 and 40?
Yep.
80 and 40, so the lower HF bands, and probably 160 as well, but I'm not sure, because aren't too many people on 160, but Ingres into VDSL modems.
That's right.
So tell us about your experience.
Okay, so let me take you on a story. So
I like stories.
it was time to get onto 40 metres, because I didn't have a 40 metre antenna,
Okay.
and the perfect place to put it was end-fed, so from my office down,
Of
we were on
course.
an internal block.
Yep.
So lovely long run.
Yep.
Perfect. Did it, but of course, you hear things about got to be careful with end-feds and make sure that you isolate, because otherwise you get stuff running up the coax.
Yep. Common mode.
Common mode, yeah.
Yep.
So when I was on 40 metres, any time I would transmit with any sort of power, when I say any sort of power, like above 5 watts, so basically whenever
So
I
above
transmitted...
QRP.
Yeah, that's right. So whenever I would transmit, we'd lose our internet connection. Now,
Which probably would have pissed off the rest of the family.
well, see, it was a really bad timing as well, because my wife had the flu or whatever she had, so she was stuck up in bed for a week, bored out of her brain, and the only thing she could really do was just watch the stuff online, right?
Okay.
And so she kept being knocked out, and I was sort of meant to be working, and so my internet connection got knocked out as well, and so I thought that, oh, you idiot, because I built my what do you call it, transformer, like a 49 to 1 transformer.
Okay.
And then I did some funky sort of a pretend BALUN on the line as well to try and strip. So I thought, all right, well, that doesn't work. So then I went down the journey of building a super BALUN, and I put that on, and it didn't work. So I thought, all right, maybe I need one right at the feed point, and I need one right at the shack point as well, right? Okay. So I had 2 super baluns, and it was still wiping everything out. And I should say, like, so the way I was testing it to try and see, you know, is I'd have a ping running.
Yeah.
And and I was using CW.
Yep.
Just, I figured at least that way
continuous
you get
wave. Yeah.
And so I'd start and I'd do a dit, and I'd be watching my ping running, right? And then I'd do a slightly, and then I'd do a da, and at some point you'd just see a drop packet, and I'd go, whoa, I better stop there, because then I could get away with testing without bringing down the internet.
Yeah, and without having to restart the modem and all that sort of stuff.
That's right, and it's a rubbish modem, so it took like 15 minutes every time you restart. Right. Anyway, so nothing would solve it, and I just got to the point of thinking, oh, this isn't going to work, I don't know what's going on. Did a couple of searches, nothing came up. And then I just must have hit the Google food jackpot. And I found a link by, I've forgotten it's an Australian, obviously he's Australian, amateur operator, VK3V something, or 5VE, maybe? Anyway. And he made some comment about NBN and being susceptible on 40 metres, dropping out your connection.
Yeah.
So I went and did a bit of a search, and it turns out that, let me find the cover. So the NBN actually publishes a paper specifically about amateur radio interference on VDSL2. And I read this thing, and it's like, it's not my antenna. Well, you know, it's not my transformer, and it's not my balance. So
it's the technology that's being used that's susceptible.
That's right. And so,
cool.
So I managed to solve the problem.
Okay.
And so, so Justin asked me, is it worth coming in and talking through the paper?
Here.
And I thought, well, that's a cracking idea. So I thought I would take you through the pertinent bits.
Okay, cool.
And hopefully everyone can learn from it. So I guess to start with, most of us who had ADSL or ADSL2 and never had any issues, right, is because ADSL on the line, we're talking obviously copper. So
copper pairs.
Yeah, if you've got fibre, then you're in Disneyland Dream World.
Yep.
I don't. But yeah, with copper, it used to go from 2 megahertz, signals up to 2 megahertz.
Yep.
And that's all that ADSL2 used to do. Yep. Come VDSL2 Plus, which is what NBN uses, and it goes all the way up to 17 megahertz, which amazingly incorporates 7 megahertz and 3.5 megahertz. So that's where our 40 meter and 80 meter interference comes in, right? So I guess the first thing to be aware of is going, oh no, the NBN's mucking up with the amateur stuff, and it's not, right? Because the signal power on their pairs is 28 milliwatts, right? So we're talking very, very small current spread from 25 kilohertz to 17.5 megahertz. So that small current is spread over a very broad range. So they are not interfering with us. It's just good to clarify that.
This is ingress from us into this technology.
That's right.
Correct.
And so for people again who may not be familiar, is if you've got fibre to the node, which is what I've got.
Yep.
So we have fibre running to a little box, and that's up to 1 kilometre away from your house. So that serves quite a few people.
Yep.
Or you can have fibre to the node. Sorry, not to the node. Fibre to the curb.
Yep.
So that comes down your street basically, and then it's just a couple of 100 metres. You've got stuff there.
That relies on the copper.
That's right.
Yeah, for that last little bit.
And so a couple of the characteristics of the copper line that are worth mentioning. So the copper lines are twisted. So they twist it, and the reason they do that is we want to minimise crosstalk interference between the different lines.
Okay.
Not every twist is the same. So some within your pair, some are twisted a bit more tightly than others.
It's a very loose sort of twist.
Yeah,
if you've ever taken the coating off of the phone line, if the cream phone line,
and they do this, and they have different twist rates so that we have different so that they don't cross talk between each other. And it also stops RF signals coupling to
Correct.
the wire-ish, because we'll get to that in a moment, because it doesn't do that entirely.
Correct.
So the reason that they twist the wires is so that if you do get any interference, the interference is going to get both wires equally.
Yep.
So if you have them as a flat pair, right, a flat pair, and it's coming from here or whatever, you may get more current or more interference on this line than you do on that line.
Yep.
So we twist them. So the idea is we have the same current on both.
Yep.
And that's our common mode current. Okay, so we've got the same current on both wires. The way that the NBN works on copper, though, is they use differential mode. So they purposely put different signals down both wires.
Yep.
And then the benefit of that is that you can have common mode, and you can have your what's the other term? Differential mode can coexist on the wire, because at your terminating, people who know XLR like audio cables, it's the same principle.
Yep.
The idea is at the end you can say on these two lines, which signals are exactly the same on the two lines.
Yep.
So those are our common mode, we can do whatever we want with them,
Yep.
and which are different, and those are going to be our differential.
Yep.
So in the case of NBN, what they are doing is they're saying, all right, any signals that are the same common mode, strip it out, and we're just going to keep the signal then that's different.
The differential signal.
Yeah. And when that works, everything is wonderful, and your internet works fine, and your NBN works fine, and your amateur radio operator doesn't upset anyone.
Correct. And everybody in the family is happy.
That's right. Yeah. Yeah. So the problem comes in when our common mode gets converted to differential mode, right? And there's a phrase that they use, and I think it's just a beautiful, beautifully said. So I want to actually read it because it's lovely. I thought I'd highlighted it. But they basically say, once your common mode current is converted into differential mode, or vice versa, the egg's been scrambled, and you're not going to unscramble the egg and pull them apart again. So the issue is how we're getting common mode onto there in the first place. Because if we never got any common mode there, then we wouldn't have to worry about conversion.
Correct.
Right? Correct. So let's first talk about how common mode gets onto those cables. So the twisted pair acts like a long common mode antenna. So a lot of the time it's buried, so it's probably insusceptible, but it has to come out of the ground and come into our houses. And so once it's out there, it's now basically a receiving antenna that's going to pick up that thing. So for us not to pick up common mode, for it to pick up common mode but with no conversion, first the two things that have to happen, the lines have to be evenly and well twisted end to end.
Okay.
And so we'll come back to this in a moment, but the end-to-end bit is important.
Okay.
And the entire circuit between the modem and the node must be well balanced. So what we're talking about, we know this from our antenna theory, is we're talking about impedance changes. So anytime there's an impedance change, or which can be from a joint that's not quite right, corrosion, things becoming wet, or where our uniformly twisted cables, it's not uniform, or there's a junction or whatever, suddenly we have a mismatch, and that's where our differential mode can get converted to, our common mode can get converted to differential mode and cause unbalanced issues, right?
Cool.
Now, the really scary part is, I'll get to the scary part in a moment.
Scary part.
Yeah. So when that happens, obviously you've now got differential mode, which shouldn't be there, because now we've got noise. We've introduced noise into the differential mode, and that's going to propagate along our VDSL2 plus line. Right? So the scary bit is, once it gets on the line, it'll travel down the line, and it's going to get to a junction, and that might be at your house, and at which point it's going to, again, our antenna and our mismatch stuff, some of it's going to continue on the journey, and the other half is going to reflect, right?
Surprise.
So now the scary bit for me when I read this and I was having these issues is when it reflects, it can reflect out, and when you're on fibre to the node, it can reflect, if it's a strong signal, all the way out to that node, which is now serving every house within about 1 kilometre. And so it's going to hit the node and reflect again and come back and then go, whoa, hello, all these houses. Can you be my friend?
Yes.
And so suddenly all these other people around you are going to be having issues as well. So that was pretty scary for me.
Okay.
And we got some lovely neighbours, and they were coming and asking about this massive big antenna. And I thought, oh no, are they asking because, or when I say massive, it's just long but thin. Are they asking because their internet's not working? So I did go and check, and they said, no, it's all fine. So, but that's a scary thought to think.
No.
You know,
you may be affecting the immediate houses around you as well.
Yeah, that's right. Well, not even just immediate, like
Correct.
within a kilometre.
Yeah, back to the node.
Of wire length, yeah. Okay, so then how do we stop this happening?
How do we fix it? Yep.
So we've gone through what the issue is, and so how can we address it if we come up here? I love the term that they use. It's called cable and connector hygiene. So if you know,
we all need hygiene.
Yeah, that's right.
Good hygiene.
We all need cable and connector hygiene.
Yes.
So it raises a point. It said that obviously you've got the stuff that the telco installs from the point to your house. It's nice, shielded.
Yep.
It's nice, uniformly twisted. They're not. I assume they're not skimping on the cable that they're using, right?
Correct.
The problem is when it hits your house, and somebody installs some cable, right?
An accredited installer.
That's right. Installs some cable, and doesn't think about amateur radio. And again, to be fair, why would they?
No, correct.
They just put Cat3 cable in, which
is perfectly okay.
Which is perfectly okay, except that it's not well twisted. And it says generally it's if you've got a pale yellow or a grey cable, like that's going to be a Cat3. Doesn't have very good twisting. Often, worst case scenario, it actually has no twisting at all. It's just, the flat cable.
It's figure of 8, basically.
That's right. And so there's nothing. So very, very susceptible to picking up your stuff. Now, this is something that gives you. So we had the scary bit. Now this is the save me bit, right? Is it saying that your cable is actually only going to bring up or pick up interference in the immediate vicinity.
Correct.
And so when they say the immediate vicinity, what they're actually talking about is within a few tens of meters of your antenna, your transmitter, or your feed line, or your cable. Sorry, we're not going to say antenna, we're going to say aerials. Because that's something we learned today, is that antenna is more American and aerial is more, from British. And see, we're Australians, we've got the king, so we're going to say aerial from here on. Anyway,
aerial.
So it only has to be, if it's within a few tens of meters of the transmitter, the aerial, or the antenna cable part. So that's where these
you
dodgy
need to
lines,
focus your attention.
Right. Yeah, which means if your neighbours are having issues, the issue is actually from the reflection going along the line back out to them, not you directly to your neighbours. Unless your antenna aerial happens to be right close to to them.
So that narrows down the area that you need to actually potentially focus on. So that makes it much better.
Yeah, and then so from there, there's two main issues that we need to deal with. One is the cable itself. So I was fairly fortunate when we built the house. We're under our stairs is where I've got our pipe server and our rack and our patch panel and things like that. So this dodgy Cat3 cable was going there, but I also had a Cat6 cable running. So what I was able to do is just where the ports were in the wall, because it's our kitchen and the toaster lives there, and if I move the modem there, then the toaster would have to go under the stairs, and that's really inconvenient for breakfast and so forth. So
and probably dangerous, but anyway.
That's right. So I was able to just basically bridge the connections, and use that cable run back to where the patch panel was.
So basically, you went from a Cat3 to a Cat6. Piece of cable.
That's right.
And a Cat6 is very finely twisted. That's one of the reasons you can run much higher rates over Cat6 cable.
And longer lengths and so forth. So the paper actually says to consider replacing it with Cat5 or Cat6. So it's not just a lance. Hey, this could be
okay.
Yeah. And then so there's your cable side of it. And then the other thing are your connections. So remember little bit earlier, I was saying the cable needs a consistent twist from all the way, including the ends.
Yep. Yeah.
And so what that means is your connector hygiene, to use their nomenclature, is you've got to get that twist going right until you get to the
which is no mean feat, actually.
To the
Can I
port.
just say, having terminated some RJ45s,
Yeah, that's right.
it's just...
So it's worthwhile having a look at. So this is inside where the weight rack.
Okay. Let me zoom in here. So,
Okay, so that's a photo inside my wall, or
Okay.
not inside the wall. That's where with the port removed.
oh, okay.
So on the left is my Cat6 run,
Okay.
and on the right is, you can see the black cable coming out of the wall.
Yep.
And that is the
phone.
main line from the house.
Yep.
And then the lighter coloured one,
Yep.
that's basically, it was joined with one of those snappy lock things.
Okay. Yes. Yeah.
But you can
these
see
things.
the white and the blue lines where they're joining, and it runs to the port
Yep.
itself in the wall.
Yep.
Like, there is no twist on them at all.
No.
They were just out and wide, and because it's much easier, obviously, to install it like that.
Correct.
And so what this paper is saying is you really need those twists to be consistent, and to, when they plug in to the port itself,
Yep.
you want to get right. And with proper RJ ports,
Yes.
you should be able to terminate
Oh no, right
with,
up to the
with your
connector.
twist, right up there.
Correct. And right, literally keep the twist going where they feed into the back, and the insulation displacement connectors, or whatever connectors you're using, that you can keep those twists going all the way, literally, to where they go into the insulation displacement connectors.
Yeah, that's right.
Yeah.
And so I did that. So I made sure everything was nicely twisted.
Great.
Wherever we had extension ports in the house,
Okay.
I went there as well, pulled the thing off the wall, made sure it was twisted. Obviously, you can't match the twist in the cable because you don't know what it is. So I just made sure that they were twisted.
Yep.
Put everything back in again.
Yep.
Went, yes, I'm going to have crushed this now. And went out again, did my dits, right? And like, it all fell over because I went straight to the DARs because I thought, this is done. And it all fell over again. I went, oh no. But anyway, so what I did is I went back. So the photo I showed before, that was where the line comes into the house. So that's the first
Okay.
place. And
Okay.
I thought, right. So the issue is that it's the article, or this paper's already spoken about that light coloured Cat3 stuff. That it's no good.
Yep.
I don't know about anyone really, or maybe some people still do, but we certainly don't use our extension lines in the house anymore because we've got our landline, which most people don't even have anymore, is cordless phone. And so I thought, well, we don't need those Cat3 ports. And so I just cut off the extension.
Okay.
And that solved it. And
So it was actually being picked up by the Cat3 cable.
that's right, yeah.
That's the key message there.
And I guess part of it is it makes sense because that was the cable that was exposed and running through the house.
Yep.
Whereas the other one, it's just come out of the ground and it's really not exposed
Yep.
to the air or anything, or to the radio waves.
There's very little of it exposed.
Yeah, that's right.
That's correct.
So once I was able to get rid of that, then
Yep.
we were done. So cable hygiene.
Yep.
So get rid of cable you don't need.
Yep.
Connector hygiene, and then it makes a special mention of those snappy locky. What are they called?
Insulation displacement connectors. Yeah, the snap lock
Yeah.
things.
Scotch locks.
Yeah, Scotch locks.
Yeah, and it says they're evil, and so
Excellent.
yeah. So basically, if you're having issues, try and do away with those and replace them with proper RJ ports,
Correct.
and bridge them with a proper cable if you need to.
Cool. Now we're hang on. We've got a few people on the we've got Richard. Good evening. We've got Muzz from Sunny VK4. Hello, Murray from Sunny VK4. We've got Ron. Spare a thought for those of us who, with an aerial phone cabling to the house. Oh, aerial phone cabling.
That's suspended. Yeah.
Yes. Oh my goodness. And we've got David. Good evening in Hobart, and Andy Cowley. Good evening. He's Europe. Sean. I got the old black figure of 8 aerial cable that goes to the junction box and the power pole. Yep. Okay. Huge problem. Now, VK3 CRG, huge problems with fibre to the node. NBN tried notching out the frequencies, which is what they talk about here at the end.
Yeah, which we're about to get into.
Yeah, so we'll go into that. And Craig actually upgraded to fibre to the premises, so there you go. Excellent. Scotch lock. Scotch lock. Sorry, yes, excellent. Thank you, Sean. Scotch lock. And in fact, they're Scotch connectors. That's actually the brand, as in Scotch tape. Same company. The entire court moved to Telstra's 5G deal, and it was faster and far more reliable than fibre to the node. Well, there you go. Excellent. Richard just chimed in there. Squish crimps. Squish crimps. They've got gel in them, I think, don't they, Richard, to stop the water getting in, I think, from memory. Anyway, so now.
So if none of this works and you're still getting issues and your internet's disconnecting, they provide a section on what's it called?
Richard's just said, Roger, there is a squishy they're squish. They've got squishy gel in them. Yeah.
So they provide some details that you can actually. We won't show you what filters look like. Everyone knows how to build filters, but basically, if you can build a notch filter, they show there. So these are the VDSL signals and how it's going across the 70 and the 80 meter band.
So the blue is the signals that they use, and then in here is where we've got 80 metres and where we've got 40 metres.
Yep.
So.
Although they use that whole spectrum.
Yeah.
And so basically what it's saying is you can notch out the amateur frequencies from where the line goes to your modem, and what that will do is the protocol that they're using is good enough that it will correct for those losses.
It's dynamic.
That's right. So
it'll find where it can send a signal through and where it can't.
That's right.
Yeah.
However, the one thing, when I was reading about some people who've done this, they said one of the issues is they get a slight loss in their
because it can't
VDSL speed.
Correct.
Yeah.
It can't use the whole bit of the spectrum.
Yeah.
That's the issue. This is so bringing back memories of BPL that it's scary. Because they were supposedly notching the amateur frequencies, but the problem is ingress of the intermods into those notches was shocking. You know, because it's never like that, and there's nothing there, because everything that was around it, because you're talking about OFDM, which is the same sort of stuff, orthogonal frequency division multiplexing, the type of technique they use means that you get all of these mixing products up and down the band, which is the problem. Anyway.
Yeah, so...
Fantastic.
But I think if that's what you need to do,
yep.
The fact that you lose 10% of your internet speed, I think we can probably live with that.
Correct.
To be able to use 40 and 80 metres.
Yep. Well and truly.
I'm just glad I didn't have to go down that road.
Yeah. Well and truly. Now, what we'll do is on the comments section of the video, we'll put a link to this paper. So if anybody is experiencing those sort of issues, they at least have a first port of call.
Yeah, but if you do a Google or an anything search just for NBN Co 4080 meter amateur, like it's one of the first two links that pops up, so it's actually really good.
Cool.
And the other thing, just briefly, a shout out to NBN Co for creating this document and hosting it. It's probably one of the best officially released documents to show you how to mitigate an issue for us as amateurs in a hobby. It is so well written, very accessible, very practical in nature. Absolute props to them for doing that.
Very understandable by the cohort that it's aimed at, which is, I reckon there might have been some amateur involvement in writing that particular document. So full credit to NBN. And NBN also, I mentioned to to Lance earlier that NBN had some issues with AM radio interference with wireless modems, and they did a firmware update. They also did a hardware update, and they were able to fix that particular problem. So they are. It appears that they're a bit proactive in trying to resolve problems, which is absolutely fantastic. So yeah. Now we've got Lionel from New York State. Good evening, morning, very early morning. Yeah, Andy and Lionel were having a bit of a chat there. So now, one thing I forgot to do at the beginning of the show, I was just going to point out that I'm actually wearing a bit of Australian amateur radio history. I managed to get this, and it still fits me, which I thought was interesting. Might not fit me down here, but I'm not going to show that. This is Amateur Radio Action. So this was the magazine in the 80s that was competition to AR magazine. And it had QRZ with the fox and the guy chasing the fox. Now QRZ obviously is who is calling, so it's a good introduction if you wear this and people go, "What's that mean?" And they go, "Oh, who is calling?" You know, you can. So this is a bit of Australian amateur radio history that I'm wearing here. So probably worth quite a lot on eBay, but I'm not selling it. So yes, and it was actually given to me by a very good friend, VK5DG, David Giles, who's doing a whole lot of satellite SOTA activations right at the moment. So he's taken it to the next level. So shout out to Dave if you're watching. So yeah, so fantastic, excellent. And you have actually fixed the problem.
Yeah,
so,
totally. So full guts, 100 watts. Constant carrier, just hold that key down and baby it works.
No one in the neighbourhood's complaining.
Do you want to know the good thing? So for those, most people wouldn't know this, I've been learning Morse code and learning, CW. And one of the things, like the reverse beacon network has never ever heard me and picked me up. And I think it's probably because, I'm straight keying and whatever. Anyway, I was a bit paranoid about just, 5 watts, and then I keep turning the power up and just holding the key down. Every time you bump it up another 25 watts, the signal's going further and further. So I was punching out my call sign, testing, call sign, testing, it's just so make people grumpy. And then by the end of it, somebody sent me a note to go, "Hey, saw you on the reverse beacon network." It's like, yes! That wouldn't have happened if my internet wasn't broken. So there was a win out of it all, anyway.
I love it. I absolutely love it. Oh, good stuff. Good stuff. Yeah. Okay. And you're upgrading to a paddle. You're going to.
Well, yes, because I'm doing an intermediate.
This is very impressive.
What are they called? CW Ops course.
Okay.
And they don't want people using straight keys. You've got to use a paddle. So. Yes.
Okay.
So I'll have to learn how to didn't die that way now.
I look forward to how it goes. In fact, I'm lending Lance a paddle. This is actually worth showing. This is actually worth showing because it's a really nice. It's actually a really nice. Oh, that was a very deadly transition. This is actually one that I picked up a while ago. This is a piece of steel, so it's certainly not going to wander around the desk, and it's actually a handmade key. It's not a commercial key.
Oh, right.
It's actually handmade, which is one of the reasons why I bought it. It's on a very nice little bit of acrylic to insulate everything. They are wooden paddles. They are actually wooden paddles. And one's the ditch, one's the DAS, and you've got a whole lot of little adjustments in here, which I doubt you're going to need to adjust, but yeah, it's and then it comes out to a 1/4-inch jack. So there you go. So that's on its way to the Lance household to go to the intermediate level.
That's right.
I love it. So are there assessments in the course and all of this sort of stuff where you actually have to?
No, but you have twice a week. You have an online thing with a I think the cohort is about 5 or 6 students,
Okay.
and the mentor.
Yeah.
And twice a week you have an hour session, and they basically, there's a whole lot of work you've got to do between every. You're meant to do stuff 6 days a week.
Yeah. Okay.
And they basically, you've got to have your progress ready for the next thing, because it's not come along and every twice a week we'll do some work. Like, it's, you've got to be working, and we're just making sure that you're on track. So
commitment is you need the commitment.
Oh, absolutely.
That's
And in a way, I think when you in a structure like that, it helps with the commitment.
Yeah.
Than just doing it on your own.
Okay.
Because to date, I've just sort of been motivating myself, and so it'll be quite nice to have a bit more structure. And yeah, somebody. Yeah.
Oh well, there you go. I love it. Well, enjoy the paddle.
Yeah, thank you.
Yeah. Cool. Now, can I get you to go and grab Tony?
Yep.
VK7XTC. That's our next.
Sorry.
No, that's all right. We'll deal with that.
So these documents are also really good to soak up spilt tea.
Yeah.
We've discovered.
Yes.
Thank you, NBN code.
I love it. Okay, this is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night. That was a nasty transition. But we're now the next particular segment that we've got is we've got also actually there's quite a bit going on in the Discord channel. But Tony's been doing some bits and pieces with baluns and made some very interesting baluns. One particular balun, and he's also brought the antenna in with him. So yeah, it's I thought, I've got to get Tony on. Come in. We've got to get Tony on to show these baluns. So now, look at this.
Won't worry about that.
No, we'll show that in a sec. Just leave it there. Yeah. Absolutely fascinating. Cool. And now, I think this is your first time on.
Yeah, I'm not real keen on being on public display, but anyway.
Now this is Tony, VK7XTC. So welcome.
Thanks.
Now, I just outlined we on the Discord channel there were some posts from Tony and some pictures of a very nice looking dual core balun, and I thought I think we might get Tony on to talk about it.
It's my fault for showing, but anyway.
He won't show anything more on the Discord channel from now on. So probably first, what tell us about the project. So what were you?
Well, just a bit bored at the moment, so I thought I'd go and do a few park activations.
Okay.
So I built the portable doublet.
Okay.
For 40 metres.
So this is squid pole.
That's a squid pole, 7 metre squid pole.
Squid pole. And comes up to here. You've got your dipole.
Yes.
So each
40
element?
metres, 10.1 metres each side.
Okay. Cool. And
it's a lightweight wire from soda beams.
Oh, okay.
Yeah.
Okay. And it's got a little eyelet on the end.
Yeah, just for the
end
for the string.
So, and then it comes to a nice bit of 450 ohm
ladder line, 12 metres.
Okay.
So that's a nice length, 32 feet. So it'll be easy match.
Yep.
With a tuner.
Okay.
And then I had to build the balun, so I could plug it straight in and use the internal tuner.
Cool.
On the 746.
Okay.
So that was the idea of building that.
Excellent. So that just comes out to 2 lines at the end, and so we'll go across to the balun now.
I'll leave the resistors in there for now, but they'll get the idea.
Cool. So let's just take that off. This is the interesting bit. Now let me we're on. That's better. Let's do a nice transition here. So what are we looking at?
You got 2 toroids. They're all 15 material toroids from Jayco.
Okay.
They're the biggest ones that they sell.
Okay.
The wire is from Jayco as well. That's 1.25 enamelled copper wire.
Yep.
8 turns.
And
on
it's,
each.
can I just say, it's really confusing enamelled copper wire because it's not the dark enamelling that you're used to. It's the light enamelling. That's actually enamelled wire, and the problem is when you scrape it off, it doesn't look
You
that
can't
much
see
different
it, no.
to where it's not scraped
You
off.
just turn your iron up to full and burn it off.
Oh, okay.
To solder.
Okay. Oh, that's good. I didn't know that.
Yeah, you just turn
Okay.
turn the iron up to about 450, and then it'll just burn off.
Excellent.
Yeah.
So you just put enough heat on it, and
Enough heat
basically
on the end, just hold it on there with enough solder,
yeah.
and it'll just burn it off, and then it'll
Oh, there you go.
yeah.
Well, I've learned something tonight. I just couldn't. I got this stuff and I went, this is an enamelled copper wire. Then I got the multimeter out and I put it across it and I went, oh, yes it is.
Yeah, you probably have an adjustable temperature iron, same as me.
Yeah. Well and truly. So, 2 cores.
Yes, and it's a current BALUN, so it does. It just evens up the current going up and down the ladder line.
Yep.
So it's balanced.
So the ladder line's onto these 2 banana
Terminals, yep.
terminals, and comes in, goes to each of these, and then they're in the particular
Yeah, it
arrangement.
goes around one winding, then it goes around the other core, and then comes back again before it comes out. So it changes sides
Okay.
as it comes.
Which is
through.
how it does that balance to unbalanced transformation.
Yes.
Okay.
Yes. And it also works as a common mode choke.
Ah, okay.
That's-
Excellent.
Yeah.
So nothing's coming back down.
Nothing's coming back down the coax.
Cool.
And it evens up. The current's going up your
The-
balance line,
Yeah.
so
I
that
hear.
it doesn't radiate.
Fantastic.
Yeah.
Okay. Hey, now, what's the resistors?
The resistors is 2 100 ohm metal film resistors
Okay.
in series.
Yep.
And that's just for testing with the antenna analyzer.
So that's we're looking at 200
That's
ohms
a test
here.
piece.
Yep.
Yeah, 200 ohms.
Yep. Okay.
And you can put it on the antenna analyzer.
Okay.
And
Do we want to do that?
yep.
Oh, we'll come back to here. We'll put it on the.
And you can just prove operation. You probably want to get it going, and you probably take a
Yeah.
shot.
Just.
Oh, somebody dropped it on me out there.
We got batteries that jumped out of the. Oh, there we go. It's percussive maintenance.
Anyway, we'll set it for, say, 7 megs.
Okay.
So just bring it down. And that's within band plan. So it comes up as 51 ohms and 1.02 SWR.
There we go. So, there we go. 7.146.
50 ohms.
50 ohms, 1.01, so you can't get much better than that.
No, and
And
if you change up
no
the
reactance.
switching and go up the frequencies or down the frequencies, you'll just just change the big
Oh.
knob on top.
Yep.
So that'll be up around 12 megs, I think it'll be roughly. And
Exactly the
it's the
same.
same. So
I love it. How does it change even higher? Oh, bit.
it'll go up to 30 megs if you turn the side dial.
Little bit.
Yeah, it starts drifting when you go up there, and I'd say that'd be the size of the toroid and the material.
Okay.
But it's usable.
But
It's usable with the tuner. You
we're
know,
still. Well, there's the limit. So
Yeah.
that's 30.4.
1.09.
I can't complain about that. Definitely can't complain about that. And then come down. So
Come down.
let's come down. Well, here's 80 metres.
Yep.
There you go.
Yeah, it's really good there.
Fantastic. I love it. I love it. Proving that it's doing its job
It's transforming
well and truly.
correctly. Yeah.
Well and truly. So, fantastic. I love it.
Bloody technology.
At least it wasn't me this time. It was me last week. Okay. We got a comment from Muzz there for for Lance not getting rid of my stroke key anytime soon. Okay, there you go.
Oh, okay.
I think we need to Lance to give us a little bit of a jig along with CW, I reckon. So and what you're thinking about here is Parks activation mainly.
WWFF.
Okay.
Or just Parks on the air, either one.
Yeah.
But
Okay.
I was thought about going down to Harts Mountain National Park.
Okay,
An
yeah.
easy one to get to, and
Yep.
drive in and set up.
Well and truly. Well and
good
truly.
elevation.
Here,
So,
here. You definitely got height gain even at the car park level.
Yes. That's
so-
what I planned on. I didn't want to trek or carry gear too far. If I can just drive on somewhere and
Yep.
set up and use it.
And the 746, how much power is that capable
It's
of?
100 watts.
That's 100 watt.
Yeah.
Yeah. So, hey,
Yeah.
fantastic.
And these usually, or they can, tune up in 6 metres as well. So
There you go.
with the internal tuner.
Okay. I love it.
Yeah.
I love it. And what size is this squid pole?
Oh, I'm not sure. I think
It's
what
six or 7 metres?
Oh, it's 7 metres.
7.
Yeah. 7
Okay.
metres.
I love it.
It's a bit short. I've taken the last metre section out, which is a bit like
Oh.
a fishing pole. They're fine. It's not worth using.
No.
No.
And in fact, the squid pole that I use, it's this segment that the little
The eyelet
strain
again,
relief
yeah.
goes over anyway, because I had it originally with a hole the size for that, and it was all over the place.
Yeah.
So I did the same
Yeah,
thing.
this stuff from Soda Beams is fantastic. This wire.
Fantastic. Well, I look forward to the report about worldwide flora and fauna or POTA.
Yeah, well, I'm hoping to if I don't have to work Sunday.
There you go. And it's a well, it's not really a long weekend, but Tuesday is Anzac Day. So now Anzac Day contest. That's a good segue.
Okay.
Anzac Day
Didn't know
contest.
there was one.
WIA has a Anzac Day contest. So very similar. I think it's just an exchange of signal reports and call signs. There may be some other things in there, so have a look at the website. We'll put the link on the
Do they use
on
the
comment.
AX prefix on Anzac Day?
Yes, they do.
They do?
Yes. So I think I'm right there. I need to check that. But there is the Anzac Day contest. Only recently, I think it's only been run 1 or 2 times.
I'd never heard of it.
So yeah, yet another contest that you can participate in on Tuesday. So yeah, worth a bit of a look. Cool.
No worries. I hope I did something for you anyway, at least.
Oh no, well and truly, and very impressive dual core BALUN. And somebody mentioned there's another design where you put those 2 cores together.
It's the same one. You just stack them on top of each other.
Yeah. Okay.
Yeah.
Okay. Is there any advantage or disadvantage or?
I really don't know. It's probably saving space. I really don't know.
Okay.
I prefer it this way because you can turn them around. You've got the input on one end and the output on the other. But when it's stacked on top of each other, you've got to get the coax in around or feed it from a SO239.
Yeah.
You've got to work out how to feed it internally with a short bit of coax.
Okay.
And I just find this simpler and
Oh, no.
tidier for myself.
Well and truly.
So that's the only reason I do it that way.
And you can actually see more easily what they're actually trying to do with the windings.
Yeah.
So
I think they handle a little bit more current too because they've got a separate toroid for each side.
yeah.
Instead of having both windings on one and heating it all up when you're using higher power.
Okay.
But-
Fantastic. That's excellent. Thank you, Tony.
That's it.
No, well that's fantastic, and keep us apprised of how it goes and any other projects because there's a fair few projects going on out there, I think,
Yeah, I'm always tinkering at home, but yeah,
and fixing radios and things like that.
is trying to. Yeah.
I love it, and dealing with crappy things coming from another country.
Obsolete parts. Yeah, getting fakes. Yeah, it's really annoying
And
and
I
frustrating.
feel your pain. I feel your pain.
I found suppliers now to get the obsolete parts in England.
Yeah.
So it's a good
That are
source.
reliable.
Yeah, good, reliable. It only takes a few weeks, but there's no rush.
But at least you know when it comes, it's actually going to be the part that.
Yeah, I've had 6 components from there so far, and I've only had one faulty one.
Okay.
So yeah,
Okay.
so I can't complain. The new old stock. So
Actually, I might get the name of that.
little diode.
Little diode. Oh, well, that's easy to remember. Little
I
diode
think
in
it's .co.uk. I think
okay
it is. Yeah.
in England. So good stuff. Okay, fantastic. Thank you.
No worries.
And thank you for sharing. I look forward to the results. So and very neat little antenna as well.
Portable doublet. Yeah.
Well and truly. I love the 450 ohm coax. That's
I love working with it. So
I actually use it on G5RV.
yeah,
That's the balance line part of the G5RV.
yeah, I've got the same setup at home as my home station,
Okay.
and it gets around the world easily.
Yep.
On low power, on FT8 and whatever.
Okay.
So
Okay.
works well.
I love it. All right. Fantastic. Thank you very
Awesome.
much.
No worries.
We'll change over. We've got a few things going tonight, so we'll be changing a little bit. So thank you very much,
No
Tony.
worries, Justin. Thank you for having me on.
Easy peasy. All right, this is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night. Now, have I got something for you? AR Magazine. We said last week that we were going to do some reviews of AR Magazine, and I've got some supporting evidence. So how's that? You can't get much better than that. One of the lead articles in AR Magazine is actually a very interesting article, and in fact I think it might be the first one in the articles. There's the West... Yes, it's the first one, which says it's timeout for leap seconds, and an expert explains why. The pesky little IT and internet clock adjustments will be paused from 2035. And this is by Darryl Veach, who is the Professor of Computer Networking at the University of Technology in Sydney. And he goes on to say that in 2035 they are actually pausing the leap seconds. Now, if you bear with me, what I'm going to do is, for those people who don't actually know what a leap second looks like, have I got a deal for you? I, back in 2015 and 2016, was able to, whoops, let's go back that way, was able to capture the leap second in 2015 and also the leap second in 2016, and this is the 2015 leap second. Now, this is using my GPS disciplined oscillator. And there is a wonderful VK4 GHZ display on the GPS disciplined oscillator. I have now put it into a case. It was all not in a case, but you'll notice here's the countdown on the 30th of June 2015 at 23:59, 60. I'll do a little dance there, but you'll notice it went from 23:59 to 23:59, 60. You actually saw an additional second put in there. And so that was the 30th of June in 2015. Now the next video, I think this will go on to the next video, is the 2016 leap second. Same piece of equipment. You'll notice that this is the 31st of December 2016. UTC time 23:59. We're counting down. It's using a Trimble Thunderbolt, which is the GPS disciplined oscillator that I'm actually using, and this display is reading the readout of the data coming from that Trimble Thunderbolt. Here we go. It's coming down to 23:59, 56, 57, 58, 59, 60. Now it normally doesn't have 60 in there, but that was the addition of the leap second, and it went to 01 January 2017. So they put that in at the end of the year. So there you go. That was that was the 2015 and 2016 leap seconds. So that's the article in AR Magazine about the fact that they're pausing them as of 2035. So that will put the world's timing systems into chaos. No, I'm joking. I'm only joking. Now, the other articles that are in here, 2023 Australia Day Contest Report. Now, the notable entry in the contest report, in the single operator phone section, there is VK7IAN, India Alpha November, who I assume is Ian, who got 97,192 92 points. So did very well as the second in the single operator phone. Of course, the first one was VK5 PAS or AX5 PAS, who got 826,294 points. So on you, Paul. Now the single operator digital, who is AX4 ADC, was up in 3.2 million, and in fact most of the top 5 are well above 1 million points. So there you go. The digital modes are where the points are. The next article in AR magazine is an International Lightship and Lighthouse Weekend report from 2022, and there is some fun and frolic on the ILLW, and there's some great pictures in here about the Cape Nelson Lighthouse and the activation. Stephen Warrilow, VK3 SN, Christmas Island jaunt, Christmas Island holiday with a DX jaunt. So can't complain about that. Across to Christmas Island and doing some DX, so absolutely love it. Now there's part 2 of Peter Wolfenden, who is the WIA historian. He wrote, this is part 2 of the how the WIA's AR magazine came into being. Now AR magazine is 90 years old. It's been in continuous print for 90 years, so it's pretty impressive. And this is the part 2 of that particular article, and some fantastic, fantastic old pictures of the old versions of the magazine. The Newcomer's Notebook, which is looking at bipolar transistors. A great article by Jim Tregellis, and we saw Jim's antenna analyzer earlier that Tony had, VK5 JST, and Jim's put an article in here about crafty project mimics speech by pulsing a 1 kilohertz audio signal. And this is, dude, ditch your whistling rig or amp test and build this popping pulsar. So this is a little board that enables you to test your transmitter and amplifiers from Jim Tregellis. The next article, a novel shack earthing hack using copper pipe and using the copper saddles that are on the pipe and soldering them so that they become earthing points around the shack. And basically putting a piece of copper pipe around the shack connected to your RF ground. The next article, Peter Sumner, VK5PI, dude, Yagis should have round booms and parallel elements. So an interesting little article on how to drill and make sure that everything in your Yagi is lined up and all aligned, and some great little jigs that you can make up to ensure that actually happens when you drill your boom with all its elements in it. And you can see there's some great articles here which show that the jigs obviously work because all of those elements are absolutely dead straight all the way along the boom. Adding Anderson power pole connectors to a Manson switch mode power supply. Many of us run Manson switch mode power supplies, and this is how you can either do a little 3D printed escutcheon for your Anderson connectors, or you can buy the actual Anderson ones and then put Anderson connectors on your Manson power supply by Peter Forbes, VK3QI or VJ3P. His contest call sign. Now, part 2 of Luis Di Stefano's VK3AQZ, his homebrew 400 watt T network antenna tuner. It's the part 2 of that. This is a pretty impressive antenna tuner. And this is fairly substantial part 2 of that particular article, telling you how to finish that off. Alara, well, the Alara column by Jenny Wardop, VK3WQ, and a big promo of Lara Meet, which is in November this year, and it's down here in Hobart. So Reast will be doing some helping out a little bit with that particular event and doing some things. Now, Mark Hillman, the WIA DX Awards. The latest on who's who in the DX Awards. That's AR Magazine, and this is number two for 2023. Volume 91, number 2 for 2023. So great lighthouse on the front cover. So that's AR Magazine, along with some some leap seconds for you. So just to show you what a leap second actually looks like. Next week we don't actually have a DATV night, but we've got a bit of a special night with a bit of a special presentation. We've got Hayden of Ham Radio DX fame, who is actually giving us a talk on the recent move of VK7RAD to become VK7RHT, so Romeo Hotel Tango, and it's back on the mountain, back on Mount Wellington. Now, there's nothing too remarkable about it being put back on the mountain. That's where it used to be, and that's its old call sign. However, there is now some voting receivers. There is one on the mountain, which is suffering a little bit from descents, which is quite usual, being right next to the transmitter and being up on the mountain. But there is another voting receiver here in the Queen's Domain, and that's listening on the same frequency and transferring that up to that signal up to the mountain to be broadcast. And then there is also a transmitter and receiver. The transmitter will be in simulcast, and the receiver will be another voting receiver, which will be down on Grey Mountain, which is, for those who don't know, Grey Mountain's down by Cygnet. Reasonably substantial mountain's got a big communications facility on it, and there will be a voting receiver and a simulcast transmitter. So the simulcast just means it's very, very accurate in what it transmits. It transmits on exactly 146/100 in the same way that the mountain does. So there will be some fantastic coverage of the southern Tasmania from that particular transmitter, transmitting from the mountain, so 1,270 metres up in the air, but also receiving in multiple points and voting receivers in different places. So it has some big ears to hear signals with. So there's a presentation by Hayden next week on how all of that system particularly works. And the other good thing is, with the voting receivers, there is a wonderful little website that you can go to, and I'll put the link on the comments section. You can go to and actually see the receiver RSSI level that it's receiving on the various voting receivers. So as you move around and you can transmit, you can actually see the various levels that are happening in the voting receivers. So fantastic little facility. So that's next week. Now, the week after that, on the 4th of May, the 4th of May is actually FIO Marine. We've got Brendan from FIO Marine coming in, telling us all about subsea communications, and specifically a bit of a demonstration about their acoustically activated buoys. And these are devices that they can send a particular sequence of audio tones to. They sync or they come to the surface. They can do something with them, transfer some data, whatever they need to do, and then they give them another sequence, and they sync to the bottom, and they sit there until they hear the next sequence. So pretty impressive stuff. And there's all sorts of techniques to be able to transmit and receive through seawater, because seawater is pretty dense medium. So yeah, it should be a fascinating talk. That's on the 4th of May. It's up here. We will stream it and go out on RF. So that's what's ahead. And of course, our June is our VK7 centenary. So stand by for a whole lot of activities associated with that. So that's our program tonight. This has been VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night. And this is VK7 TW Justin bidding you 73. Have a good week, and we'll see you next week at the repeater talk. Cheers.